Welcome to a new week. Our warm-up was about numbers whose factors add up to the same number if you don't count the factor that is the number, right? So for 6, 1, 2, and 3 are small factors. They add up to 6. We're not counting the 6 itself. We checked it for 9 and 10 and 14 and 16. None of those added up to the original number. But we're getting close with 16. It turns out the next one is less than 30. And if you weren't here in class, that's the only hint you get. But the people who showed up got to read a little more. Okay, most of this ToDoodle is about how to multiply. And this, I don't think, is terribly important for the GED. I'm not sure. I finally got signed up to take the GED myself, and then I can talk about what's on it more intelligently. But I'm not sure it will ever ask you just to multiply numbers by hand. This is something that happens mostly so that if you were taught something before and know it only as a mechanical process and don't know why it works, then that might make you not feel as smart. So we'll talk about why it works, and then you'll understand it and feel smart. Also, some of these methods are more popular in different generations. So often if you are a parent of a kid in school these days, the multiplication method they are using in their book isn't the same one that you are taught. And that can be frustrating because they want help with their homework and it doesn't look the same. So it's sort of those social reasons why we're doing this, not that I don't think someone on the GED will say, here's 2 3-digit numbers, multiply them without a calculator. That's just kind of a long thing, and everyone on math tests makes careless mistakes. So that doesn't really measure anything about your math knowledge and problem solving. Okay, I'm going to start by comparing two things, and they're written out. I could write them again as I go, if that helps you. And I have on the next page a bigger version of this. So I'll actually start talking about them on the next page. But here's sort of the issues. The first method, we'll just call the traditional method. It looks like this. You write the two numbers on top of each other, and you put a line under them, and then you multiply. Another method is called the box method or rectangle method, because you're writing the numbers in a rectangle. And as many digits as they have, that's how many rows and columns you're making. So we've broken up 31 into 30 and 1 as 2 separate columns. And we've broken up 25 as 20 and 5 in 2 separate columns, and then done something. There's also something called the lattice method, which involves some diagonal lines happening also. But you could call this the lattice method and be a little sloppy, but people will sort of still understand what you're talking about. So we're going to look at them and compare them. And this might just be that one of them is the one you're used to, and great, now you know why it works. Maybe none of them are sort of yours, and you want to make one of them yours. Which one is easier to understand? Maybe it's the one you've seen the most. Or maybe you're thinking, oh, I wish I grew up with the other one. Maybe one of them is just faster to do, and that's what you want. Or maybe one of them takes up less room on the paper, and that's what you want. So there's good and bad parts about both of them. So let's explore. Everyone ready to kind of go through them, or is there more sort of what we're going to talk about questions that people have?
I'm ready.
Ready? Okay. So with the traditional method, I'm writing 31 and 25 as just the numbers the way I normally write them. I'm going to start with my ones digit on the bottom, and this is sort of like an anchor spot. I kind of imagine that I have one of those like lawn sprinklers, and it's kind of shooting out in every direction from that spot. First, I go 5 times 1, and that gives me 5, so I write it underneath. And then my lawn sprinkler goes this way, and I have 5 times 3, so that's 15, so I write it here. Everyone with me so far? Then I pick up my lawn sprinkler and I move it to where the 2 is. And now the 2 shoots out this way. 2 times 1 is 2, and 2 times 3 is 6. I put a placeholder 0 here before I start writing things with the 2. Can anyone figure out why when I switch from 5 to 2, I have to put a place value 0 there?
Because we don't know the number yet.
So there's a number to add to.
It's in the tens place.
Yeah. We're not really adding. It's not like plus 0. That wouldn't change anything. You're meaning, when you say add in English, in this case, you're just meaning combine with something, not the arithmetic operation of adding. And what we're combining with is what Ruthie said, that this is not really a 2, this is a 20. So I'm doing 20 times 1, and 20 times 1 isn't 2, it's 20. And 20 times 30 is actually 600. So because I scooted over a place value here, I have to scoot over a place value when I multiply. There's a hidden times 10 in all of that. But in any case, I've now done all of my lawn sprinklering, right? We've started here and gone this way and that way. And then we've started here and gone this way and that way. All of these numbers have had all the combinations. So I add things up, 5, 7, 7. So I'll ask for comments in a moment, but then let's look at this other one. This might be what your kids in 4J are doing, if you've had kids in 4J recently. Then they say, let's make this box and we'll break apart the 31 to make it very clear that that 3 is not a 3, it's a 30. But that 1 really is a 1. And this 2 is not a 2, it's a 20, but the 5 really is a 5. And once I've labeled the outside of my box, so imagine for a moment that this box, so far I'm just setting up the problem. Then I start multiplying to make everything match. And I've color coded it so you can see how the two things compare. 5 times 1 was 5. And here in the same blue, we have 5 times 1, like playing Battleship, where they meet is 5. And 5 times 3 was 15 in green. And here, 30 times 5 is 150. And then there's no moving down. This place value we did, because the 2 is really a 20, we can see the 2 is really a 20. So 2 times 1 is really 20 times 1. So that's the red 2, the 20. And 2 times 3 is really 20 times 30. So that's 600, the yellow 6. Now, there's no easy lining it up like we have automatically happening with this method. So we have to actually go off to the side and add up these 4 numbers, 600, 150, 20, 5. And when we add them all up, then unsurprisingly, we get the same thing as the other one. But it takes another step, another part of the paper to kind of finish. Does that make sense? My one is not looking like
Yeah, it does.
So I'm not saying you have to do both of these, and maybe you don't even have to do either of them, but you will probably see them, and hopefully the comparison helps you see what's happening. Okay, now we'll take questions. Questions about either side?
I don't know if this pertains to the whole thing, but why did has this style, the box style, been out for a long time, or did they just start doing this with map?
It's probably related to both the Common Core standards and what state you're living in, probably adopted different books. You are now asking a question that both about government and publishing companies. And there is a problem. Like, as someone that's been teaching math for a long time, then if you actually read the government requirements, these Common Core standards and things, it is fairly well written. But to try and find a published curriculum for elementary school students that does a good job with it is nearly impossible. You wind up with these workbooks that drive parents crazy, and the kids aren't really learning any better or differently, and so on. So there's a giant disconnect between what the people that understand how brains work and how we can teach things to help kids learn want done, and what the book publishers figure out what to do.
Understood.
So yes, you're smiling like that's not news to you.
No, I get it. I just never understood why it went there, because my son went through this and he's still going through
I
it.
am going to
so.
show you now. So when you need to learn algebra, this is nice. So what would happen if, do I have it on the next page? Was I, no, I was not done. So one moment, let me grab another little box. What happens if, and I'm going to do this on the same page so that you can see it, but it's going to be a little cramped. Instead of 31 and 25, we were doing 31 times 2x plus 5. So this problem is now 31 times the quantity 2x plus 5. And since I am writing in algebra instead of the x for multiplication, I'm going to use a dot. So you don't have to really follow this now, because now we're doing algebra, which is not our math topic, but it's exactly the same, right? 30 times 2 x's. Well, if I have 2 x's 30 times, I have 60 x's. If I have 2 x's once, I have 2 x's. 30 times 5 is 150. 5 times 1 is 5. Let's add everything up. I have 60 x's, and 2 more x's is 62 x's. And 150 plus 5 is 155. So maybe that makes no sense to you because you've never learned algebra, and that's fine. Maybe it makes some sense whether or not you've learned algebra. But if I'm multiplying two things and there's some letters, x's or y's in them, you can do this exactly the same as if there's plain numbers. Whereas this one, not really. So that's why they started teaching the box method, because then when your kid gets to algebra, they're using what they had learned before. Okay, I would ask for questions, but I'm going to do so hesitantly because it's not really our job right now to talk about the algebra. But other than like, I'm almost getting it, please help me, which could be an after class question. Any more questions before we move on? Okay. Now we get to something that's just weird. So oops, I closed the wrong thing. Oh, well. There's a third way that I only learned about recently as I was researching things. So Lewis Carroll, who wrote Alice in Wonderland, invented his own method. And he thought this was pretty cool. No one else had ever heard of it in modern days, but now you will be extra special. The problem with his method is that you have to take the top number, the 31, and write it in reverse. So 31, right? Whatever started as the ones digit goes now on the left, and whatever the biggest digit, tens, hundreds, something, goes on the right. So here's what's going to happen. We're going to take this paper where we took the 31 and wrote it backwards and start sliding it across the top. And when we multiply things, then it's always straight down. So 5 times 1 is 5, just like we had before. 5 times 1 is 5. Then we're going to slide the paper again. And we have 2 things. So we've used the 5. Maybe I can even just slide it over there. 5 times 1 is 5. Now we move the paper. Now I'm going straight down. 3 times 5 is 15. And 2 times 1 is 2. So I'll add them up together and get 17. And then I'll put the 17 there. And now I'll move my paper again. There's nothing above the 5, so I don't do that. There's nothing below the 1, so I don't do that. The only thing that's still lined up is the 3 and the 2. So right underneath them, I'll put the 6. And then when I add up everything, 5, 6, and 7. Well, 7 plus 3 is 10, and 3 more. Carry 235. It didn't match. What did I do wrong? 775. The 6 must be over here. What did I do wrong? This is the problem with me not ever doing this before. 3 times 2. Why did he write the 6 there? Anyway. So there's this weird method. No one's ever used it. Maybe you think it's a lost treasure and you love it. But even I can't explain it well. But it was kind of interesting how you only multiply straight down rather than all this diagonal stuff that happens with the traditional method. Okay. Your turn. So that's been a lot of watching me use my pen. That's no fun. So in the Jamboard, use the arrow tool. And the problem is done on the right, 70 times 9. Right? This side, it's all done, and we know what the answer is. Your job is to fix this side by dragging things around. You might need to use the double click the arrow tool so you can edit these numbers and change them, because they're sort of overlapping, as you can see. With everyone grabbing the same stuff, you're probably going to want to talk to each other, or you'll just wind up fighting over colored numbers.
I pulled off the 45 from the top.
Okay, I am going to pause the recording though, so you don't have to feel embarrassed about working together. Okay, so we have fixed this one now. There was some carrying that we had to do to include the 4 from the 45 with this tens value 5 to make it a 9. Then there wasn't this ugly overlap. And similarly, the 1 from here carried over to the hundreds to make that 4 into a 5. And then we could add things up and it just looked nicer rather than how we started a moment ago with overlapping things. Okay, comments?
You wanted me to repeat it?
Yeah, for the camera, so that everyone who was sick today can say, it wasn't just me, Cheyenne said the same thing.
Okay,
Together.
so I said that I was always taught the left method growing up, but I was never taught the ones place and the tens place and the hundreds place. So that totally blew my mind and made so much sense. So
So, and that's the point of this. No, I don't think anyone will ask you to do this on the GED, but you are well-educated people. If you were not taught well as earlier in your life, that's not your fault. Now it makes sense and you can say, yes, I am smart. It was not my fault before. I didn't understand it. And go write nasty messages to your old teachers that don't remember who you are anymore, because no, don't do that. Okay. So there's a problem with what we did today, that we saw different methods of doing the same thing. And some students love that, because if they can understand lots of methods, then they feel smart, right? I understand 2 methods. I'm twice as smart as when I only understood 1 method. And they like this kind of being a control freak. Oh, there's 2 ways to do this. I can pick either way and do my favorite way. Wah, ha, 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 ha. And if you only knew 1 method, but they like the other one better, then yay, step up, improvement. Those are all perfectly valid feelings. On the other hand, there's students that absolutely hate this kind of lesson. I just want to learn 1 thing and practice it until I'm good at it. I don't want to have to learn 2 things, and I certainly don't want to be assigned to like do group work with somebody sitting next to me and we have different ways of multiplying. That's a pain in the neck. And there's this trust issue where you might not really believe that your teacher, when they say you only have to learn 1 method, really means it, because they've had teachers in the past that lied and said you can learn either way of multiplying, but then on the test you actually had to do 1 or the other or both or something. So those are all perfectly good things. So I'm not going to ask you to share in the recording, but just think about what kind of student are you? Are there reasons you have other than these 6? And if you are the top kind of student, how do you deal with the drawbacks below? Or if you're the bottom kind of students, then how do you deal with the drawbacks above?